Exercise A04 is of a different kind, I shall say. When I finished exercise A03 in the previous live coding video screencast, you saw that I was testing my program. Well, the purpose of exercise A04 is to force you to test your program, and we're going to enforce this habit because it is really critical to acquiring solid programming skills. You cannot just write something that you think is right and just then drop it and say, I'm done with my work. You need, every time you write a program, to try to assess whether it does the intended job correctly or not. We have been already discussing about that in the lecture and in the previous exercise. So the only thing I would add here, since I already tested the program at the end of exercise A03 video, the only thing I'm going to add here is try to give you a better idea on how you can come up with a strategy to test efficiently your program. So let me take an example. We have here the code for our program. Let's have a look at it. Everything is sequential execution here until we bump into our first conditional. Conditional means two possible paths of execution. I would like to make sure that I test both. So what is my conditional? If choice equal 1. Well, instantly I look at this and I'm thinking, well, I'm going to have to test my program with choice equal 1 at some point and choice different than 1 to be able to test both branches of this code. If I look up, what other variables do I have? A and B. Okay, so let's go to the drawing board and try to come up with a test strategy. How many variables do I have? I have variable A, I have variable B, and I have variable choice. Value of A and B, well, they don't seem to really be influencing the outcome in terms of choice of execution path. So I'm going to just arbitrarily decide that A will be 300, as I did in my previous test, and B will be 10. Now, what I just said about the first conditional of this code is that if choice equal 1, it triggers the first conditional. If choice is different than 1, then it triggers the else part of the same conditional. Here we go. Let's go back to the code real quick. So we're talking here about testing those two execution paths. If choice equal 1, what I expect to have on the screen is the sum of A plus B. That's going to be the output of my program. So if I go back to my drawing board, what is my expected, I'm going to abbreviate, outcome. My expected outcome is the sum of A and B, 3 and 10. What is my observed outcome? Well, I'll see that when I run my program, and if I notice that something is different between what I expect and what I observe, then that's a pretty good indication that I have a bug here in my code. Okay, let me go back to the flowchart. This is taking care of our first if. Second if choice equal 2, I test this. If not, well, I have another value. I will catch it by another conditional later on. So if choice equal 2, and I can keep the same value for A and B, I expect to see 300 minus 10, 290. Observed outcome, I will see when I execute my code. Choice equal 3, same thing. I expect this time to have the division of A by B, which is 30. Observed outcome, I don't know yet. Choice equal 4, I expect to have 300 times 10, 3000. This is my space for the observed outcome. And then what? Well, as I insisted in my previous video, this is not enough. What if I give a negative number? What if I give a number bigger than 5? Okay, well, all of those are going to be in different test cases. For example, I can test -1, I can test 5. You will notice also that during the first module we discussed about data types, and I indicated that Raptor was not really a programming language which enforces very seriously data types. Okay, a variable can be a string, an integer, a floating point number, etc. Well, what does that mean? That means that in Raptor, when I ask the user, please give me a number between 1 and 4, obviously they can choose a number that is not between 1 and 4 and type it. And my program will have to cope with that. This is what makes the program robust. However, they can also enter a string. They can also enter a floating point number. So when you think about the little exercise that we're doing right now, you are mainly focused here. You are mainly focused on determining that your program behaves appropriately when given appropriate input. Then you want to keep an eye on how does my program behave when I provide wrong input. So this first part here is about correctness of your program. The second part here is about robustness. And this includes, of course, also all those weird input. When we use a programming language like Java, we will be able more easily to catch this kind of weird nonsense. And to a certain extent, it's still going to be the responsibility of the programmer to catch both of those nonsensical input. And we are done with this exercise. So what I want you to do by hand now is deploy your own test harness, your own set of test cases, okay, like the one indicated here, and make sure that your program provides in each case as observed output the expected output. There we go.